Hello everyone, very good afternoon. My name is Shri Krishna. I am your learner success manager for the day. Before we go ahead with the session, please let me know if my voice is loud and clear. You can confirm in chat box. Excellent. Thank you for your confirmation. Please let me do a quick audio check with our instructor. Hi Rahul, for audio confirmation, please let me know if my voice is loud and clear.
Hi, Shri Krishna. Yes, your voice is loud and clear.
Yeah, we can also hear you clearly. Now I will make you the presenter so we can get started with the session. Happy learning everyone.
Yeah. So, hello everyone. Let's wait for everyone to join in. Then we'll start with the session as the strength is currently low. Hello everyone, good afternoon, good evening, good morning. I hope I am audible to everyone. Okay, good. So just a verbal recap of what we did in previous class. So on previous weekend, in fact on previous weekend, we completed the pandas library, and then we started talking about the visualization piece, and we came up with the name matplotlib. And what is matplotlib? Again, a library in Python that is used for visualization, one of the most commonly and widely used libraries in Python. That is what matplotlib is. And then we went to the homepage of matplotlib, and post that we also looked into uh, how to how what are various graphs that it supports, and how do you install it by using the pip install matplotlib command, and how do you work with it. So we looked into those things, and then we started looking into the line plot as well, how to make a line chart. And post that then is when we started talking about scatter plot, and that is where we ended our class, because we'll have to talk a bit. And because I mentioned that scatter plot is used for uh, seeing the relationship between two variables. Now we have to talk about what those relationships are, what are various measures and all those things. So that is where we are currently. So we'll be in today's class. First, I'll take you to the matplotlib code scatter plot, and then post that. Then we'll start talking about the statistical parts, or the measures of central tendency, dispersion, relationship, kurtosis. So we'll talk about those things, and then we'll come back to matplotlib part, and when needed, we'll start going back to the statistical or theoretical part as well. So this is what we'll be doing. But yes, before moving ahead, anyone having any questions, please put in your questions. So Lakshmi says matplotlib can't install matplotlib. Okay, what is the error that you are getting, Lakshmi? From where are you trying to install it? But where are you running the command pip install matplotlib? Where are you running it? What is PGM? Can you give me the full form? You need to run the pip install matplotlib command in the terminal or your command prompt, or in case if you are using Anaconda, in your Anaconda prompt, Lakshmi, not in the program. If you are running in program, you need to put a isolation mark before it and then run it. But the ideal recommended method is to run it in the terminal or the command prompt or the Anaconda prompt in case if you are using Anaconda. Okay, so then is when it will be installed. You're not getting any output because you're running it in the code, and simply your kernel keeps on running and running and does not do anything. That's why. Okay. Okay, perfect. So then let's move ahead and let's talk about other pieces. So let me share the screen and let's start discussing other parts. Okay, so let me open the matplotlib code and then let me share the screen. Okay, please give me a few seconds. I hope my screen is visible to everyone. Okay, so this is the part that we started in the previous class, where we started talking about what matplotlib is and how do we import it. So matplotlib.pyplot is a PLT. So this is what we import and use for plotting the graph. Then we imported our data, and on top of this data, we started making charts. We started talking about line graph first, and what is the use of line graph. We talked about that, and post that, then we looked into how to make a simple line chart, and how to even make multiple line charts. And all of you were also given a task to make 3 to 4 line charts, and you were able to do that as well. And post that, then is when we came to scatter plot. That what is a scatter plot? This is first of all what we call as a scatter plot. What is the use of it? It is used to visualize the relationship between any between two variables. That is what it does. Now the question comes, well, what kind of relationship are we talking about? So in plain sense, it tries to show the linear relationship between two variables. Now, what is that linear relationship? That is what we'll be talking about. And before that, we'll talk about where does it come in, and what are various measures. So that is what we'll do. So hence, we'll be moving to the theoretical part now. We will be studying a bit of statistics, interquartile range, percentiles, and those things. And then we'll come back to this graph once we have the understanding of what relationship is and what does it indicate. Then is when it will be the right time to look at this graph. So let's move to the blackboard and talk about the statistics and those parts. Any questions, anyone, please put in the chat in case if anyone has any questions. So I see there are no questions, so I hope everyone is clear so far then. Okay then, let's move to the OneNote then. So I hope my screen is visible to everyone, the blackboard. Now what we'll do is we'll talk about statistics a bit. Why? Because we need to understand when we are saying a relationship, what is linear relationship, and all those aspects. That is what we need to understand. So hence, let's talk about statistics first. Now, what is statistics? All of you might have heard about it for sure. You would also have studied it in your colleges or senior secondary. So, in plain sense, it is a branch of mathematics. Please give me a second, everyone. Okay. So statistics is a branch of mathematics which deals with data collection, data analysis, and interpretation. Also, spelling of mathematics. Just give me a second. Let me correct it. Okay, so statistics is a branch of mathematics in which you collect data. For example, you might have done a lot of simple questions if I talk about, because that is what everyone would recall, of calculating average, calculating the range, calculating standard deviations, variance from your data, correct? So statistics essentially deals with data collection. You are collecting data. When I say data collections, you might think, how does it fall under statistics? Because there are various methods of collecting data: random method, stratified method, Bernoulli random sampling. So there are various types of data collection strategies as well. And post that, of course, the data analysis, where you try to analyze the data, and then based on that you interpret some things, or interpret some ideas or decisions, or what the data is trying to say to you. Then you kind of draw some certain conclusions. That is what the interpretation part talks about. Okay, statistics is broadly classified into two. It's broadly classified into two. Can anyone tell what are those two? The first one is descriptive statistics, correct? Correct. Descriptive. Descriptive stats. And the second one is inferential statistics. So correct. Now, what is descriptive statistics? What does it do? So this involves so this involves summarization, organization of data so that it can be easily understood. So just to kind of revise the whole part, so we started talking about the matplotlib visualization, and we were at scatterplot, where we want to look into the relationship. And to understand the relationship, we need to know what type of relationship we are talking about. Essentially, linear relationship, how to quantify it. So to know those things in detail, that is where we have come to this blackboard, or the theoretical part, where we are learning about those things. But before learning even those things, we need to know the basic parts. Hence, we are learning first the statistics. Like what is statistics? Because many of you might have forgotten it. So what is statistics, and then how it is classified: descriptive stats, and another one is influential stats. We'll talk about that as well. And what is descriptive stats? This involves summarization, organization of the data so that it can be easily understood. Okay, what does the data, what information does the data carry? And the second one will be now the inferential statistics. And then we'll be talking on these in detail. Inferential stats. Okay. Also, please give me a second. Okay. Second one is the inferential statistics. What is inferential statistics? That we draw certain sample from the population, and based on that we do certain predictions. So this part involves making predictions about a population based on the sample data of the population. Means what it is essentially saying. So if you look at closely at the name only, it says inferential. We are drawing inference, correct? We are drawing the inference of what? Inference of a whole big population in which a lot of people are there. So we are drawing an inference. How? By simply taking a smaller portion of it and doing a test on top of it, and then we say that okay, this is how the population would be. Now your question would be, why don't we take the whole population? Because sometimes due to limitations of cost or time, we cannot simply take information of the whole population. If I ask you to note down the weight of all the people in a country, it would be practically not possible, correct? Because by the time you are done weighing people, there would be billions of or millions of people that would be newborn, or newborn infants would be there, correct? So those who will also have to be included. And by the case, let's say if you say that okay, I want to weigh people from 15 to 20, by the time you are done noting the weight, many people would have uh, exited 15 20, and many would have entered 15 as well, correct? So it's directly not possible sometimes due to various constraints that you note down the data, or you can say information for the whole population. Okay, does it make sense so far, everyone? Okay, so now what we'll do is we'll talk about these in detail as well. Please give me a second, everyone. Okay. Now, what we'll do is we'll talk about various parts of this. Now, just to highlight, or you can say further talk on this. So descriptive stats involves various parts of uh, like the parts that we'll be studying right now. Measures of dispersion, measures of central tendency. So all these will fall under descriptive statistics. And for inferential statistics, it will be various tests that we'll be learning down the uh, course, hypothesis tests and those kind of things. That is what we'll be going through, in fact. Okay, so we'll be doing that. So I hope everyone is clear till this point. So let's move ahead now. Okay, now let's talk about. So just to mention that as well, this involves example, various measures. That is what we'll be studying right now, and this involves testing, confidence intervals, and so forth things. Okay, now let's start with the measures part. And all of you would have, all of you would know this for sure. Measures of central tendency. Can you tell what are the measures of central tendency, everyone? What are various measures of central tendency? And what, first of all, even before talking about various measures, can you tell what is the intent or what is the use of this particular part? What do you understand when someone says what that what like the question is what are measures of central tendency? What do they help you with? What do you think? What could be the answer to this? Correct. So if I try to write this, it would be they're used to determine, they are used to determine or describe, whatever you want to call it, the central or typical values of the data set. Now, mean, median, mood, range. Range again is a part of central dispersion. But again, mean, median, mood, these are part of your measures of central tendency. So, for example, let's start with the first one, that is mean, or you might also call it average. However, there is a slight difference because in terms of population, you might call it average. In terms of a group, you call it a mean. But again, so the first measure of central tendency, the first measure of central tendency is mean or average. Now everyone knows about it for sure. But again, just to tell, For example, if you have a data, so if you calculate the average, often denoted by x bar or mu is equal to 1 plus 2 plus 3 divided by 3. So what is this 3? These are the total number of observations. And what are these? These are all the data points. Okay, so in our case, this is how it will be calculated. Now your question would be, then when do we use x bar, when do we use mean? So in case if you are doing a calculation for a sample, so this is, you can say, used for sample mean, and this is used for population mean. Like let's say all the people you wanted to target, you are having the data for all of them, so we tend to use mu. But in case if you are if you know that the subset, or you can say the set for my experiment would be very very high, and I'm only taking a group and trying to derive information from that group and map it to the population, then of course we tend to use x bar, because that's a sample and not the whole population. Okay, so that is the difference. Now if, and this is what the formula looks like. If I try to write this formula a bit more mathematically, so it will be summation of xi from I 1 till n divided by n. So this is the formula uh, of what I've written over here. The same thing I've written much more uh, generally, in fact. Okay, so this is the first measure of central tendency. So just to recap, we started talking about statistics. What is the statistics? What is statistics and how it is divided? It divided into two: different, descriptive and inferential. What is descriptive? Simply helps us to uh, get the summarization or organization or describe the data in plain sense. Whereas inferential is that we take a sample and from that we try to draw conclusions for a whole population. Post that, then we started talking about measures that are the part of descriptive statistics. So if I try to kind of label it, so all these measures which I've written over here as well are part of uh, descriptive statistics. So we started with the first measure of central tendency. What are these help us to look into the most typical or the central values present in your data set. And the first measure of central tendency that we studied right now is mean or average. Okay, so the second part is median. So let me use the same color. The second part is median. Now what does median do, or what is median? Median is the, and again, I do know that most of you would be aware about this, just I'm giving you a recap, uh, because this is important. If people might have forgot, they can simply have a revision of it. That is the intent. So this is the middlemost value of the data set. Okay, second, it is useful in understanding the skewness of data, understanding the skewness of data. What is the formula for median? So median formula is n plus 1 divided by 2 each term, if n is equal to number of observations which are equal to odd numbers. Just to give you a simple example on top of this, let's say you have a data. Let's say you have a data 2, 1, 3 like this. Okay. So first what you'll do is, first step is to sort this data. Sort the data. It becomes 1, 2, and 3, and sort it in ascending order. Okay. So sort the data, and I'll write simply ascending. Post that, then you can simply use the formula because the number of observations are odd. So by using the above formula in this example, we can directly see that number of observations. So n 3 observations, 3 plus 1 4, 4 divided by 2 2. So the second observation, so this observation is the median in this case. How? Just to write the formula. So 3 plus 1 divided by 2, th term. So it comes out to be second term. So this is the most centermost value of your data. This is the centermost value of your data. Now there is a different formula if the number of observations are even. So in that case the formula goes. So I'll simply write if number of observations are even. In that case the formula becomes median is equal to n by 2 term plus n by 2 plus 1 th term divided by 2. Okay. So in this case, if observations like 1, 2, 3, 4, 2 and 3, because these are the n by 2, so 4 divided by 2 second, and then plus 1 third term. So second and third term, that is 2 plus 3 divided by 2. So 5 divided by 2, 2.5. It comes out to be the centermost value of your data. Okay. So that is what is median if the number of observations or n is equal to even. Okay. So quite simple things, but still. Now the third measure of central tendency is mood. Third measure of central tendency is mood. What is this? This is the most commonly occurring value. Most occurring value. Okay. And it can be for both numerical and categorical. For both qualitative or quantitative data. Whereas median and mean are dependent upon what? The data being numerical in nature, because then only you'll be able to calculate these values. Whereas it's not the case for mode. Mode is simply the most repeating value in your data frame. For example, if you are having a data 1, 1, 1, 2, 3 like this, so then the mode will be in this case 1. Why? Because it was repeating 3 times, most number of times. Okay, so that is what is mode. People also call it model. Okay, but again, uh, I hope everyone is clear. So any questions so far, anyone on this? Clear everyone so far? Now the second measures that we are going to study is, like for example, we talked about measures of central tendency. Now we'll talk about measures of variability. Both of them are mode you can there. Okay. Now what color did I use? Okay, blue. Now the second measure is measures of variability. Okay. Now what are these? How are these helpful in? So let me first of all underline it. So these are the tools that are used and used to describe the dispersion in the data set. Dispersion of or dispersion in data set, whatever you want to call it. The first measure of variability. So can you list down what are various measures of variability, everyone? So various measures of variability. The first one is range. So just to note it, range. So what is range? If you recall it, and let me keep this heading in visibility. So range is the maximum value of a data set minus the minimum value of a data set. The max value of the data set minus minimum value of the data set. It is the simplest measure of variability. Now you can understand what does this give you. For example, if you are having a data, uh, a lot of data from 0 to let's say a million. So in your case, it will be million minus 0. So it essentially gives you the spread of your data, like what is the dispersion or how far away the minimum and maximum value or how much spread your data is in. Okay, so that is what this value or range function tells you. A simple formula, very simple formula. Now followed by this is variance. Now, what is variance? Variance is the average squared difference of observations. Okay, let me underline it first. This is average square difference of observations in the data from the average of data. Okay. Basically, in plain sense, I can say that it gives you a sense, it gives a idea of how far, or you can say how much the data point is deviating from the mean. This is denoted by S square. S square. Okay, the formula for this is, I'll write a general formula first. N minus 1. Okay, now I hope everyone knows what this is. This is simply the summation sign. This indicates summing of observations. Okay, so just to write what xi refers to, xi refers to the data point I in dataset x. X bar refers to the mean of sample data. N is equal to total number of observations. Okay. Another symbol that you might see people using could be, if I simply put it this way, sigma square. Okay. So again, the same differences. So this is for the population, just to mention, sample variance. Okay. Just to give you an idea, what this, like how this is calculated. Let's say you're having a data, and let's say the column is x, and here it would be xi minus x bar square, like the numerator part is what I'm doing first. Okay, so let's say you have some data. 2, 4, 6. Okay, and let's, for the sake of understanding, say x bar is equal to 4. In fact, I think 6, 6, 12, 12. In fact, it's 4 only. So what will be the differences now? So in this case, it will be 2 minus 4 square, which comes out to be 4, correct? This is 4 minus 4 square, simply 0 square, so 0. And again 6 minus 4, 2, 2 square 4, again same thing. Now my first question to you is, will it make any difference if I write this formula like this, x bar minus xi square? What do you think? Correct, it will not make any difference. Why? Because this is simply a squared value. So it doesn't matter if the value is negative or positive, the outcome will be always same because it is a squared data point. Okay, so that's why there will be no difference. So in this case, now if I calculate the variance, so if I say variance will be equal to what? 4 plus 0 plus 4 divided by uh, n minus 1. In our case, it will become 3 minus 1 because we are having 3 observations. That comes out to be 8 by 2, which is 4. Which is 4. Now, if you recall, what I was saying is that it gives you an idea about that your data, how far your data point is from the mean. Now, my first question is it on the same scale as your data? Is it on the same scale as your data? Is it on same scale as the data? What do you think? The answer is no. Why? Because it is squared. It is squared. Okay. Why squared? Because you can see this over here. So we are having these values only, which are already squared. And then I'm simply doing addition of these squared values, which are simply squared. So this is not on the same scale as my data point. If my data point is 4, 6, so I cannot say that, okay, this 4 is essentially referring to this 4. Why? Because this is simply a squared value. Okay, so this is not on the same scale as my data. Okay, hence there comes a need of what? Data point which is on the same scale as our data. Hence we come up with the third measure of variability. So first one was range, second one was variance, and third one standard deviation. Why do we call it standard? Because it is on the same scale. Deviation, because it gives you an idea about how much the deviation is in points with respect to their mean. Standard deviation, often denoted by S or sigma. Again, I shall not put this column. I'll simply put in comma, whatever sign you want to indicate. It is simply under root of variance. That's it. Why? Because variance is a square value. So this under root helps bring variance on the same scale. In same scale as data. Okay. So now it will be easy for you to tell that on an average, how much is the point or how much are the points differing from the mean. Okay, so that is what standard deviation. You might have listened or heard this word a lot, but again, if you remember this very well, if not, and if this is helping you to revise. So yes, standard deviation simply gives you an idea about how far the normal observations are from their mean. Clear to everyone? Okay. Is it clear to everyone so far? Sure, Toby. Theme scale, for example, one data is okay. Just to give you an idea, let's say this is x 246, and this is x squared. So it will be 4, 16, 36. Now these are simple values, whereas these values were squared values. Correct? Getting it? So that is when I say Harmandeep that they are not on the same scale. Like whatever, let's say for example, whatever amount or money you have, I am having, let's say, square of it, for example. So we are not on the same scale in the sense that it's not comparable directly. Okay, so that is what this information corresponds to, that the data is simply the square. Okay, hence we simply do under root to bring it essentially on the same scale. If you remember physics, do you remember second square, second? For example, if there is a length is, let's say, 2 cross 3, so the area would be 3 cross 2, so 6 meter square. Correct? It's not meter, it is meter square, so not on the same unit as meter. So same is the concept over here. Okay, hence all these values are squared, not on the same scale. Now coming to the next part. Next measure. So in measures of variability, we have talked so far about range, variance, standard deviation, and now we'll be talking about the next one, interquartile range. IQR. Now IQR helps you to see how your data is in terms of spread in the central portion. Please give me Okay, in the quartile range. So this helps in understanding the spread in central portion of the data of data. What is this when I say, for example, IQR formula is Q3 minus Q1. Now what is Q3? Q3 is the 75th percentile. What is Q1? Q1 is 25th percentile. Just to give you a reference, the median is the 50th percentile, which we just did. Does it make sense? So median is a 50th percentile, like the centermost value of the data. Let's try to understand this using a simple line. Let's say this is how your data is. Okay. Now, in the centermost part is your median. Your 50th percentile. Okay. We also call this as sometimes Q2 or Q naught. Depends on or what people tend to call it. Then, so this is your 50th percentile, centermost point of your data. This is not the mean. Do remember we just talked about it. The difference between mean is that's the average, or you can say how the data is faring with respect to all the values, whereas median does not depend upon all the values. It could be that any value is occurring, it does not matter to it. It simply looks for the centermost value in your data and then gets you the value. Okay, so that is what median does. So I can see that the median is, oh, sorry, the IQR is now this part, because if you remember what IQR is, Q3, and this is the Q3. Let me just write here as well. So this is the Q3. Q3 minus Q1. So can I say that this is what is the IQR? Okay, please. Clear? Does it make sense? Okay. Now, just to many of you would be still thinking that you've not got the percentile part. So, in plain sense, you can see percentile is how much percent of the data is below this value. How much percent of data is below this value. So, for example, the 25th percentile is, let's say, a value of 18. So, below this value of 18, 25% of the observations are present of your data. Okay, so that is how you can understand the percentile part. Like how much percent of the data is below this particular value. Then you might have heard, so same way, you have percentiles from all the way from 0 to 100. Okay, so 0th percentile, 100th percentile. So 100%, like all the 100% data is below this particular value. Okay. Now you might have heard quantiles also for sure, correct? That there are quantiles Q3, and that is what I was using also about interquartile range, or interquartile, based on quantile 1 or quantile 2 or quantile 3. So what are quantiles? These are also percentiles. The only difference is that these values are 25th, 50th, and 75th only, and because they divide the data into four parts, hence quantiles. Okay, let me write that. These values divide data in four parts. If I try to write it, let's say this is your data. So the 25th percentile, 50th percentile, which is the median, and 75th percentile. These are what? These are the quantiles. Why so? Because if you look closely, your data has been divided into part 1, part 2, part 3, and part 4. That's why we call it quantile. Okay. Now, many of you might see that in this way, there are deciles also, that which divide the data into 10 equal parts. So you're correct in that sense. So deciles are which divide your data into 10 equal parts. Clear to everyone? Okay. So till this point, I think everyone is clear. Correct? The same way you have deciles. Let me change the color. So this divides data into 10 equal parts. Values that divide data into 10 equal parts. Okay. So the 10th percentile, 20th percentile, 30th percentile, 40th, 50th, 60th, 70th, 80th, and 90th are the decile values. Compared to datasets in what terms of Prajita? See, data can be compared on multiple parameters, number of observations, average values, their range. So if you talk about IQR, like can you use IQR of two different data sets to compare it? Yes, you can do it. But how will that help you? That's a different story. Okay. So these are various measures of variability that we studied right now. Range, variance, standard deviation, interquartile range. Okay. Now we'll move to the measures of relationship, which we came to study for the scatter plot. Okay. So, and these all are part of descriptive statistics to remember. Measures of relationship. Now, what are they used for? They are used for these tools are used to understand the association between two or more variables. Don't worry, we'll talk about this into much detail. See what is the association. Basically, like how are two variables impacted or how are they moving together? For example, is weight and height related or not? So they help us to determine the association between two variables. Okay. Now, the first measure that we'll be studying in this is covariance. Covariance. Now, what is covariance? Covariance indicates the extent. It indicates the extent to which two variables change together. So, covariance indicates the extent to which two variables change together. Don't worry, we'll look into examples also in detail. Okay. In plain sense, I can say it measures the direction of linear relationship between two variables. Okay, let me do that. Which part should I scroll up to? Ankit, which part you are referring to? Where should I scroll to? Okay, okay. So, as I mentioned, these are simply used to measure the direction of linear relationship between two variables. For example, just to give you an idea, example, sales and marketing budget or marketing spend essentially, let's say, but instead of budget, I would say spend. For any brand, if I try to draw this data now, so this is the how data would look like, correct? Of course, there would be exceptions, but generally, if a company is spending more on the marketing, then the sales would be also higher, and if less, usually the sales will be lower. Do you agree with me on this part? So generally, this is the trend, correct? Now, if you look closely, this is a linear relationship. This is a linear relationship. Now, how that both variables both variables change proportionately. Both variables change proportionally with respect to each other. With respect to each other means if I try to say, say this, if variable 1 is increasing, if variable 1 is increasing, so is variable 2. Correct? Like if I simply increase the marketing spend, sales will also increase. Correct? And same way, if I decrease the marketing spend, the sales is also so sales will also decrease. Correct? So both of them are moving in the same direction. If you increase one, automatically the second one increases. So can I say there is an association between them? Because me, even without looking at sales, if I say, okay, let's increase our marketing budget, we know that the sales will increase. So is there association between them? What do you think? Correct. There is a association between them. Now, because when one is increasing, the other one is also increasing, we call this as a positive linear relationship. Positive linear relationship. Okay. Does it make sense so far to everyone? So we talked about what linear relationship is. And linear relationship, we also talked about the positive linear relationship, in fact. So can you agree with me that this is a scatter plot? What do you think? Is this a scatter plot? So yes, it is a scatter plot. Just to mention that as well. So what does scatter plot help us to look? It helps us to look at the relationship or association between two variables. Now your question would be, okay, I could have done this using line chart as well. Just try to think if you would have made a line chart, this is how it would look like. Every point will be connected using a line. And even if there is exceptions, one, two exceptions over here, this is how the line chart would look. Would it make any sense to you? Because it will be connecting every point, correct? It will try to connect every point. Will this make any sense? The answer is no. Hence, scatter plots are used to look at the relationship. So we are talking about the linear relationship and we looked into the positive linear relationship. Now your question could be that is there a negative relationship? The answer is yes. There is a negative relationship. So this, let's see, this is the positive. So what's the negative linear relationship? Let's talk about that. The negative linear relationship, what happens is one variable increases and this leads to another variable decreasing and vice versa. That if you increase one variable, the other decrease. If you decrease the first variable, the other one would increase. Can you think about any example on this? The common example would be a sales and price. Let's say low price, high price, low sales, high sales. When the price is low, so we know sales would be comparatively higher. But as you keep on increasing the price, the sales will tend to decrease. correct? And of course, it might have certain exceptions, so this will look a bit more thicker rather than very close part. But does it make sense? So this is the negative linear relationship. Essentially, how you can understand if there is a relationship or not, if it forms a balloon shape, or you can say a arrow shape pointing in a particular direction. Like if you look closely, this is pointing in this direction, so it is negative linear relationship, as simple as that. Whereas if a balloon is forming up and it is in the upside direction, so in that case it is a positive linear relationship. Does it make sense to everyone? Then you might also say, is there a case when there is no relationship? Yes. For example, you are having some data, and it could be anything. The data is like any, there is no pattern around here. Rain in millimeter versus number of cars traveling, or you can say number of learners present in this class with respect to temperature. So does not make any sense, correct? They are not at all related. So hence this is no impact of variables on each other. Okay. Questions anyone so far? So is the relationship part clear to you? Linear relationship. Okay. Now there is another part to this. Now see, so far what we did, we simply took some data and made some graphs, and we were able to determine the relationship. But a machine does not have eyes, correct? It requires data, and for the data, it requires some analysis to be done on top of. When I say analysis, for humans, if I simply show you the graph, we are able to understand what the graph is corresponding to. But the machine does not understand that. Okay, it simply draws the graphs and gives you the value. So is there any method in which we are able to tell whether a particular value is linearly related or not? And if they're related, are they positively linearly related, or are they negatively related? So do we have that method? Yes, and that is what we are studying right now, in fact, covariance. So covariance helps us to look at. So covariance helps us to look into that part which I was referring to. It helps us in determining if the two variables are linearly related or not. Here, these graphs that I made was to explain you what linear relationship is, what is a positive linear relationship, what is a negative linear relationship, just to understand those parts. Okay. But what we'll be doing is, now we'll be looking into how do we calculate covariance. Please give me a second. There seems to be an issue with my OneNote. I'll have to restart it. So stopping the share and restarting it. So I hope my screen is visible to everyone right now. Okay. So I was saying that okay, we understood what relationship is, what linear relationship is with the help of graphs. But for machines, machines do not have eyes or brains that they can interpret it. So are there any numbers or formula that can help us that okay, if the number is this, then it's a positive relationship is why if the number is this, then it's a negative relationship, something like that. The answer is yes, and that's what we are studying, and we call that as covariance. So if I write the formula for covariance, let's talk about it, and then what does it indicate in fact? What it indicates, we just talked about it, but yes, I'll talk about that again. So covariance is also known as COV simply, like you'll hear names COV as well. For any two variables, x and y, the formula is summation of from I 1 till n xi minus x bar yi minus y bar divided by n minus 1. Okay, divided by n minus 1. So x bar is basically sample mean of x variable. Y bar is sample mean of y variable. Okay, n is equal to the total number of observations. Xi is the ith observation in x variable, or you can say not in, it should be, let's say, of yi is equal to ith observation of y variable. Okay, so this is, for example, if you're having any two data variables, let's say sales and marketing spend, and you want to see whether they are even related or not, whether they are positively linear, they are having a positive linear relationship, or they are having a negative linear relationship, or are they not having any relationship at all. So how do you determine it? Either you can plot it, good way, but again, if you want to have much more crystal clear idea of whether they are having a relation or not based on numbers, so that is where covariance comes in. And covariance only gives you the direction. We'll talk about that. So the range of covariance is minus infinity to infinity. Okay, this is what the range of covariance is. So how to kind of read these values? So if you are having a value between 0 and 0 kind of not included, 0 to positive infinity, so you are saying you have a positive linear relationship. Same way, 0 to minus infinity, negative linear relationship. and for 0, no linear relationship. No linear relationship. So what I was saying is that using graphs machine cannot tell, but what if do we have a number that can help us to figure out if they're having a relationship or not? Yes, that's where covariance comes in. We just talked about the formula of covariance, and then what is the range of covariance that can come up. And then I mentioned that okay, if you're having a value greater than 0, so it would indicate a positive linear relationship between your variables x and y. If the value is less than 0 towards negative infinity, it indicates a negative linear relationship. And if 0, so no relationship. So what I'm trying to say is that covariance gives you direction, that whether it's positive or negative, direction of relationship between two variables, but does not give an idea, or you can say a direct quantification of how strong the relationship is. How strong the relationship is, it does not give you that idea. Why? Why? The question could be why? Because the magnitude of covariance depends upon scale of variable. Just try to think it closely. I will talk about this. Okay. Now, for example, just everyone look closely. We agree that okay, this is the covariance formula, and it can, and as I mentioned, it ranges between minus infinity to positive infinity. And if it is greater than 0, positive linear relationship, negative than less than 0, negative linear relationship, and if 0, so no relationship. But then I specified a line stating that covariance can only help you in getting an idea about the direction of relationship, means whether they are related or not, first of all, because if 0 means they are not related. And post that, then even looking into the direction whether they're positive or negatively related. But I mentioned that you cannot tell that how strong the relationship is, means you cannot compare that okay, the covariance of let's say x and y is 10, and the covariance of let's say a and b is 20, so a and b is having much stronger relationship. You cannot see that. You cannot see that. Now the question is why? Because the covariance depends upon the scale of variables. It depends upon the scale of variables. What do I mean by this? For example, and let me write in fact here only. Why? For example, you cannot say covariance of x and y is let's say 20, and covariance of let's say a and b is simply 1. So I cannot say this way that covariance of x and y is, or you can say the relationship of instead of covariance, of x and y is greater than that of relationship of A and B. You cannot say this. You cannot say this. This cannot be said. Why? Because as I mentioned, it depends upon the scale. Means what do I mean to say? For example, let's say example one is x and y, or let's say the mass of planet, and y is the mass of natural satellite. For example, is there any relationship between the mass of a moon with respect to mass of the planet? Means we know that okay, the mass of moon is, let's say, some xyz value. So is it directly related to the mass of the planet? There could be answer yes or no, correct? But in this case, you will agree with me that the range of values will be in trillions, correct? Trillions of kgs, correct? Whereas, let's say if I have B and let's height in centimeter and B is, let's say, weight in kgs. In this, you can agree with me that the range is simply in hundreds max to max. Range in tens to hundreds. Correct? So automatically, if I calculate the covariance for this, the covariance value will be big. Why? Data scale is big. The value points are in trillions. Whereas in this case, covariance value, and let me write value instead of covariance directly. Covariance value. Okay, I've written that in fact. And covariance value is small in this case. Because both A and B scale is small compared to A and B, compared to X and Y. Does it make sense? You cannot say that, okay, the relationship of X and Y is greater than that of A and B. No. The numbers that are present in X and Y are already in trillions. So ideally, the value will also come out to be higher. But whereas same is not the case with A and B. Does it make sense? Because if you look at the formula, what we are essentially doing, we are simply taking a value from the x variable, subtracting it from the average value of that variable, y, and average value of y. So it's directly you can see. So let's say average weight of the planet is 30 trillion kgs or 30 trillion ton. Okay, so let's say 20 trillion minus 30 trillion, and here also let's say the average weight of satellite is, let's say, 10 million and 20 million, like this. So already the value is like trillion million divided by, let's say, 20 observations. So the value will be still very higher. Does it make sense what I'm trying to say, everyone? Whereas in other case, when you're taking height and weight, it would be simply in kgs. So you cannot directly compare it. Okay. So what do? We need to bring it to the same scale or standardize it. Correct? Does it make sense to everyone? Any questions? Please put in your questions. Hence, then your question would be, so what do we have? So to measure the strength of relationship we have correlation. We have correlation, which is our next measure of relationship. So the first measure of relationship is covariance. So the second measure is correlation. So what is covariance? Covariance gives you an idea about the relationship in your data, whether it's at all related or not. And if it is related, linearly related, is it positively linearly related or it's negative relationship between two variables? But it does not indicate the strength of the uh, relationship. Okay, so for that we have the second measure of relationship. We call it as correlation. So let's move and talk about correlation now. Also denoted by R, and this is the Pearson correlation that we'll be talking about. There are various types of relations correlations as well, but the one which we'll be talking about is the Pearson correlation. Okay, so correlation describes the, or you can say quantifies, I can put in a quantifies the direction as well as strength of the relationship between two variables. Between two variables. Okay. The correlation coefficient formula is, let's say for any two variables x and y, which could be the mass of planet and mass of the satellites. So the formula is simply covariance between x and y divided by the standard deviation of x and the standard deviation of y multiplied. Okay, so what does this do? This simply standardizes the data now. So this, just to mention, is a standard deviation of x variable, standard deviation of y variable. Okay, the range of this is -1 to 1. Okay, -1 to 1. Now what does this indicate? And just to write that, so value 0 indicates no relationship. Negative value indicates negative linear relationship. Positive value indicates positive linear relationship. Means So if I say that values between 0.8 to 1 and same indicates strong positive linear relationship. Same way values between minus 0.8 to minus 1 indicates strong negative linear relationship. Okay. Same way from let's say uh, 0.42 or 0.6 to 0.8. In this case, you can say medium positive relationship. Now it's up to us to quantify it, how you want to kind of say. Okay. And same way minus 0.6 to minus 0.8, and I'm just giving these numbers, but again it depends upon what value you want to use to determine. When I say what value, that you want to call minus 4 as a medium relationship or minus 6 as a medium relationship, but in plain essence I can say plus 1 indicates an ideal positive linear relationship. If I try to make a graph between two variables, let's say if the correlation between any two variables x and y comes out to be plus 1, so the graph will look like this, like a scatter plot. If you make a scatter plot between these two variables x, sorry, let me put x on the x-axis itself. So x and y, it will be exactly a straight line. Means that x absolutely related. If you increase x, y also increases by exact same value. Okay, y also increases the price, or you can say value, by exactly same number. Okay, so that is plus 1, whereas minus 1, minus 1 would be like this, that if you increase one, the other one decreases by exactly same number. Okay, the other one decreases by exactly same proportion or value. So that is minus 1. So does it make sense? So correlation between, let's say if you ask that what if the correlation is between uh, 0 to let's say 0.4. So I would say that a weak positive relationship, positive linear relationship, and same for the other value also. Now you might ask, so can I compare? Now, can I compare? Can I say if the correlation between any two variables, let's say a and b, is 0.8, and the correlation between a variable x and y is let's say 0.7? So yes, now you can see that relationship or strength of relationship is more between variables a and b. Okay, now it gives you a comparison. It allows you the comparison part. Does it make sense to everyone? Any questions? Any questions, anyone? Now there are various types of correlation as well. Just to mention, there are lot of correlation types, and every, of course, with respect to data, formula, calculation, degree. So there are many Spearman, Kendall Tau correlation. It keeps on going and going and going. So the one which we studied, as I mentioned, is a Pearson correlation. It is the Pearson's correlation. So in the negative linear relationship, the y values decreases. Yes, correct. Or vice versa. Okay, it's not necessary. If one is increasing, the other decreases. Okay. Now, so what we were talking about, just to give you a recap of what we were talking. So we started with the statistics part, and why so? Because in Matplotlib we were at the scatter plot, and the scatter plot is used for what? Used for uh, understanding or seeing the association or relationship between the two variables. But we need to know about what relationship we are looking into, okay, and what are its type and those things. Hence, we came to this blackboard and started talking about statistics and its type. So we started with what is statistics and how it is divided into two, descriptive and inferential, and then how descriptive has multiple things inside it, and again not only limited to these, of course. So in uh, descriptive statistics you have measures. So we started with the measures of central tendency, in which there were mean, median, and mood. Then we moved on to the measures of variability, which helps us to understand the spread in our data, which are range, variance, standard deviation, and interquartile range. Okay, and we looked into those data as well. And then post that, we started talking about measures of relationship, which are so we studied covariance and correlation. Okay, and what is a relationship? We also talked about that. And I also mentioned that there are a lot of types of correlation. And again, there are many more measures as well. There are many more measures of relationship. For example, chi-square test is another measure of relationship, followed by let's see, a regression analysis. So there are many more measures of relationship that are present, but yes, we'll be only limiting to covariance and correlation for our case. Clear to everyone? We will also talk about measures of shape as well, and measures of shape and kurtosis, like we'll talk about those as well. In measures of shape you have kurtosis and skewness. So one more measure is left. We'll talk about that when we are at the right graph, histograms or KDs. Then is when it will make right sense to talk about the measures of shape, which are skewness and kurtosis. Okay, we'll come back to this when the time is right. But yes, are there any questions? Please put in if there are any. Let me stop the share meanwhile. Any question if I missed by mistake, please put again in the chat. Siddharth, all these are mentioned in your prerequisite course. See, I hope everyone has gone through the prerequisite course of maths and statistics. So all these things are present in that course that we are currently going through. And again, these are prerequisite. I'm just simply picking them up just so that in case if anyone was not clear from there or has not gone through that, we are covering those things. But just to mention, Siddharth, the topics that we'll be covering post this is measures of shape. Then we'll talk about outliers and various ways to detect outliers. Post that, then we'll talk about uh, probability distributions. And in probability distributions, binomial probability distribution, Bernoulli probability distribution, Poisson probability distribution, normal probability distribution, standard normal, and uniform probability distribution. And post that, then we'll start talking about hypothesis testing, what is p-value, and then what are various tests like t-test, z-test, and their types, and ANOVA and its types. So that is what we'll be talking about if we are looking into the theoretical part that we'll be going through. Siddharth. So a lot of topics we will be discussing, of course. Okay, so I don't see any questions coming up. So let me open the pool and then let's go for the break. Post the break, we'll continue to move into the matplotlib code and discuss it in further details. And then post that, we'll talk about outliers and various measures. So there I can do that, but the issue is one node directly does not export the node, so I tend to paste it in the paint and get the image and then share the image. So a process in itself, honestly. But no issues, I'll be uploading it on the LMS portal post the class, so you can revise. Those things would not be directly used in today's class, don't worry on that part. Mean, median, mode, IQR, all these you are already aware about, but yes. Just to mention to everyone, I tend to share all the notes and codes that we discuss on the LMS portal, and you will be having the access to the LMS portal for your lifetime. Okay, so all those things, all the recordings as well as the notes and the codes are always present on the LMS portal. Any more questions, anyone? Okay, I hope everyone has pulled, so ending the poll. But I assume so far that the things that we have gone through are completely clear. Of course, you will not be able to remember the four formulas in one go. No one is able to, in fact. But you have just gotten just about what we have studied about relationship, positive relationship, negative relationship. Correct? We have got those ideas. That is what I am trying to say. Correct? Okay, perfect. So let's go for the break now. Let me share the screen and let's go for the break. Please give me a few seconds. I hope my screen is visible to everyone. Okay, so let's go for a break. See you after the break, everyone. Thank you. So is everyone back? Okay, good. So let's move then, and let's move back to the matplotlib code now. Okay, so I hope my screen is visible. Okay, perfect. So let me just run the verb cells so that the data is read in memory and we are able to make graphs. Okay, so just now, before the break, we covered the statistics and those parts, correct? And we understood the relationship that we are looking into the scatter plot now. So, what scatter plot is used for? To identify if there is any relationship or association between any two variables. So that is the first one. Second one is says that visualizing the cluster between cluster in the data, that is a distribution of data. Essentially, what this tries to say is, for example, if you are plotting some data x and y, and something comes up like this, for example, like some points are here, some points are here, some points are here. So you can visualize like how your data is distributed essentially. So that is what this point is talking about. And then the outlier detection, which we'll be talking about when we go to the box plot. So we'll talk about outliers in detail and how to detect them and then how we can visualize them as well. So that is when we'll talk about the uh, uh, scatter plot usage in terms of outliers, not an ideal method, but again can be used for getting an idea about if there are any outliers in the data or not. Okay, so now let's move ahead. So how to make a scatter plot in matplotlib? By simply saying plt. What is this plt? Plt is matplotlib.pyplot. We simply imported this with the alias plt. So plt.scatter, and on scatter we are saying df total bill goes on the x-axis and then df tip goes on the y-axis, and we are saying label is equal to tip versus bill versus tip, which is basically this particular legend that you are seeing, which helps you to understand that okay, what these dots or circles are indicating. What is the information that we want to look? Marker again. Oh, so if you remember, we also went through a website where, like in the Matplotlib documentation, where all the markers are present. So it's up to you which marker you want to use. P, capital P, small p, 875. So there are a lot of markers present in Matplotlib, followed by what edge colors you want to have for these uh, markers. So in our case, I have simply selected black. And if you remember, there are many colors that are present that you can use, totally up to you. Then I'm saying color is equal to red over here, and you can use olive, khaki, whatever you want to use. So all those things will work. If you see this, so you can see it gives you the olive color. If you put in khaki, that gives you the khaki color. So all the colors are, if you can refer to that page that I gave in the last time. So red, that puts in the red color. What is this S parameter indicating? It indicates the size of the circles or the uh, plot that you want. And what does this alpha parameter indicate? Alpha parameter indicates the intensity of the color. Okay, intensity of the color means how dark or light or how transparent or translucent or opaque these things will be. The value for alpha is between 0 to 1, and I put in a comment over here as well. Let me bring that comment in the same line. So alpha value is between 0 to 1. If I make this as 0.9, see, it becomes very dark. Do you see the intensity now? It's very, very dark. And if I make it a smaller value like 0.1, because the range is between 0 to 1. So if I make it 0.1, you see how uh, light they become. So it essentially controls the intensity of color, how intense or dark the color will be, 0.9 being very dark and uh, 0.5 medium dark. So uh, whatever value you would want to use, totally up to you. Followed by that, I'm putting a X label and I'm specifying on X axis, I want the label to be bill, color blue, size 10. So you can see that on my X axis, the same label is placed in the graph. Then on Y axis, I'm simply saying tip, and you can see it shows tip on the Y axis. Dot title, or the graph title. You can even do the coloring, size, everything over here. And the PLT dot legend over here. And let me also show the line number. And pld.legend over here, and in line number 8 pld.show. And once I run this, you can see that it populates this scatter plot. Okay. Now, if with this data, just if I what if I try to draw line plots? Let's say plt dot plot instead of scatter. Just to let's see if I make a line chart, how will it look? So plt dot plot. Let's say plot. So plt dot plot gives us a line plot, correct? If you recall it. And let's comment out this piece and see how the graph looks. Do you see how the graph looks? Does it make sense? Because it tries to connect each and every point now using the line. Okay, so it does not make sense. Hence a scatter plot, because it is not connected and can give you easy understanding of how your data is related. Hence a plt.scat now gives you an idea about okay how the data is spread and related. That's why we say that scatter plot is used for looking into the relationship of the variables, whereas line plot cannot do that. Okay. Now, see, this is my total will and tip. Correct? These are the total will and tip column. Now, if you want to get the correlation, and we just studied the correlation part as well, if you recall it, correct? Correlation helps you to understand the strength of the relationship and also gives you the direction of the relationship as well, in fact. Okay. So, how do we get that? By simply using the dot CORR function. Analyze this, what these values are saying, and do tell me what do you think what these values are. So yes, it indicates positive linear relationship. First of all, if you see, it plots the numerical, like for example, I simply did a correlation for a total bill and tip column, and then I simply said dot CORR. So this is a pandas data frame method. And because now we have studied the correlation, that is why I put it over here. So when I say df total bill and tip dot CORR, it gives me the correlation between total bill and tip. Now both the columns will be present in index as well as the columns. Hence you can see the values are getting repeated. But what does this one indicate? One indicates absolute positive linear relationship. Now can you tell why it's present over here? Because both on x-axis and y-axis total bill is present. Exact increase in on x-axis is increasing exact amount on y-axis. Correct? So that is why always between the same data, if you have the same data on x-axis, same data on y-axis, the correlation will be always 1. Why? Because data is same, so we are increasing 1 unit of x, so 1 unit of y is also increasing. You decrease 10 unit of x, 10 unit of y would also decrease. Okay, so that's why it's always 1. And then it sees that the okay, linear the correlation between total bill and tip is 0.6757. That is what this particular part indicates. Clear to everyone? Any questions? Okay, let's move to bubble plots. DF stands for the variable name where our data frame is, which we read at the top. Like this is our data frame. Okay, so where we were? We were at the bubble plot. Okay, please give me a minute. I'll be back. I need to set up a thing. Please give me a second. Okay, so I accidentally dropped. Sorry. I'm back now. So let me share the screen. Let's continue. So I hope my screen is visible. Okay. So you're talking about the bubble plot. So what bubble plot does is it simply adds one more dimension to the scatter plot. Basically, see your scatter plot over here is a 2D graph, correct? What if I can add one more dimension of the data in a 2D graph itself without making it 3D? Means instead of me looking bill versus tip, what if I can look at one more additional information? So you might say that that would require additional access. The answer is no. We can simply play around with a trick, and that gives us additional information, additional dimension in a 2D graph itself. How so? And that is where bubble plot comes in. So, and you can compare various data points as well. For example, what I'm saying is df total bill and df tip. Then I'm simply adding a tip column. Okay, and let me change this color. So what I'm doing is I'm using marker, edge color same, color gold. Now the only thing that I'm changing is that the size column, I'm not keeping it static. Initially, if you see in our previous scatter plot, what was happening? Our size was static, simply 100, correct? But here what I'm doing is I'm making the size or defining the size with respect to the size column in the data frame, in fact. So I'm saying df size multiply 100. So it's basically changing with respect to the size column now. So the size column is there's a number of people arriving at the restaurant. So that is what this column is indicating now. Alpha, same thing. Once I run this now, so you would see what is happening, and let me increase the intensity to 0.5. You will see that how there are bubbles that are very small, which indicates the size, correct? Big bubbles indicate that large number of people came in. Small number of small size indicates few people. Now, so the graph is still total bill versus tip, but we are able to capture additional information over here. That is the size of the bubble indicating what? Indicating the number of people at any instance. Does it make sense? So this is what is bubble plot. Any questions, anyone so far? Can you bit? Sure. Let's. Meanwhile, let me change the color as well. Yeah. Okay. Perfect. So I hope everyone is clear. No questions on this part. Okay. Perfect. So let's move ahead. And again, if you look at the correlation now, for example, if I say df.corr and only numeric only means only I want to have a look at the numeric columns because correlation can only be given for numeric columns, correct? Because it requires calculating average and those things. So not possible for the qualitative data, it's only possible for the quantitative data. So once you run this, you can see that there is a correlation of size column with total bill, so 0.59, and same way with the tip as well. So there is a correlation. Okay, and that is what we are able to capture. That usually, whenever the bill is high, you can see the bigger bubbles over here. In fact, because higher the size, greater will be the bill. But of course, there are exceptions. But yes. Now let's move to the pie chart. Now, pie charts are simply used to show the relationship of parts with respect to the whole. For example, every country releases a budget that, okay, this is the budget for this particular financial year, and out of that, we are going to spend, let's say, X amount on defense, X amount on education, X amount on infrastructure, X amount on this and that. Correct? So you tend to see that, okay, how much percent of the bill is going to this part. Now, with respect to numbers, you can grasp it. For example, 20%, 30%. But a pie chart makes it look much more appealing as well. That, okay, this part is getting the higher chunk. So without even looking and comparing the percentages, when there are multiple parts, it becomes very easy to simply have a look at it. So that is what is pie chart essentially. So pie chart helps you to see the relationship of various parts with respect to the whole and as well as each other. So comparing categories also, and you can even highlight the dominant categories by making a slice out, which I'll be showing in the graph as well. So very commonly used graphs as well when the parts to whole relationship is shown. Okay, so let's move ahead. So what we'll be doing is first of all, I'm making a day group by, and I'm doing the sum on the tip column. So I'm simply saying data is equal to df dot group by index is as index false means simply make the day column as a day column itself, not as an index. Aggregation tip and sum, and once you look at the data now, so this is our data. And if you look at the total tip, so total tip is 731.57. Like total tip, the total sum of this column is 731 something. Okay. Now what is happening is uh, we are saying that data percent of total. Like I'm simply making a new column just to see that, okay, how much is Friday taking the percentage with respect to the whole. So the total tip I got is 731. So how much percent I got on Friday, how much percent on Saturday, how much percent on Sunday. So that's what I'm doing over here, simply dividing the tip column with the whole sum of the tip column and multiplying with 100. That's it. So that is what I'm doing over here. So you can see that I'm getting 7% for Friday, 35 for Saturday, and Sunday 33, and Thursday 23. Okay. So the same things will be plotted in a pie chart. Okay. So now if I go and make a chart on or a pie chart on top of it, so I'm saying budget, or let's take this to, let's say, tip amount, and or let me make it label and amount. So that you will not get confused within the argument name and the corresponding this. So hence I'm simply naming it like this. Okay. Just give me a second. I'm putting it for above as well. Okay. Okay. Okay, so what we are doing is we are taking the label data, data day, like this particular column as the day, and this step amount column as the amount simply. Now, what I also want to show is that for this particular matplotlib, so what matplotlib essentially helps you to look into is that it even allows you to use hex color codes. Now you might ask, what is hex color code? So I've simply pasted a link over here. Simply go to the new tab and paste it. Let me show you what I mean by that. Just give me a second. So do you see this? This is simply a Google color picker. You click on any color basically. You go to any color scale, any color range, and whatever color you want to choose. For example, let's say you want to pick this color. Let's say this color. So do you see this part over here? This particular part. This is what we call as the hex color code. Okay. So Matplotlib even allows you to simply use the hex color code. Okay, simply copy this and paste it over there, and Matplotlib will give you this particular color in your graph. Okay, so all the possible colors are now present. In fact, that you can see, correct? So there are so many combinations that are present. So if I go back to the part over here, now what I'm doing is I'm simply making a list with colors we want, like all the colors that I want, and I'm simply pasting the color codes over here. These are the hex color codes, and again, I have already given a real link over here for you to fetch the color codes. So what is happening is now I'm making a pie chart. So I'm saying plt.pie amount, passing in the amount that I want to have, the labels, basically what labels I want to have: Thursday, Friday, Saturday, Sunday. It could be anything else, for example, admin, manufacturer, manpower, maintenance. It could be anything. Okay. And then I'm saying exclude 0.20. What this means? Do you see the slice that is currently out? It could be that you would want to discuss this slide in a meeting, or you want to draw attention to this particular slice. So that is what this is doing. So you're excluding this particular slide. That is a third slide from the starting. So third slide is essentially Sunday. Okay, so you're excluding Sunday because you would want to, let's say, discuss on this part. This is again just an example. Okay, and greater the value, further away it will go. If I make it 0.8, you can see it goes very further away. Okay, so smaller value, smaller is the exclusion. Followed by that is that if you want to convert the numbers directly to percentage, we are using this auto PCT feature along with determining will what value you would want to have this percentage. Now, if you would have gone through Python documentation, you would be aware about what we are indicating over here. I'm simply saying I want one decimal place in float value with a percentage symbol. So that is what this particular string is determining. But again, if you go through Python documentation, which I've already recommended multiple times, you'd be able to understand what this value is essentially referring to. But yes, in clean sense, this converts the data to percentage essentially. Now, post that, there is the argument that whether you want to have a counterclockwise movement of the pies or a clockwise movement of the pies. Again, it's a boolean. If you make it true, it will be a counterclockwise the movement, and if you make it false, it will be a clockwise movement. Okay. Same way, then you have start angle that you want to start from 90 degree, or you want to start from 0 degree, like 90 is this part, as you can see. What is the first part? Friday. So it starts from over here, like this part. If you make it 0 degree, so it will move from this particular degree. Is it clear? Okay. So start angle is determining the start part. Okay. Shadow, like for example, you are able to see the shadow. So shadow just gives uh, a nice good and feel touch. So this is again indicating that matplotlib allows some kind of beautification as well. Radius, how big the whole radius, how big the pie chart you would want to be. So if you make it 0.5, say it becomes big enough. Okay. And text props, what is the font size you want to have? For example, if I say 15, it will make it 15. You can see the font size is bigger. You can change the font style as well. So all those things are possible. Okay. So this is the pie chart. Any questions so far, anyone? So you covered pie chart, bubble plot, scatter plot, multiple line charts. So a couple of things. Let's look at the bar chart, and then what I'll do is I'll give you the code to go through and practice, and then we can move ahead. Let's cover one more graph, and then you can take the code for the revision part. So now the next plot is bar charts or bar graphs. So you might have looked a lot in bar graphs as well. First of all, this is what bar charts are. Okay. So what are they used for? Couple of things. You can compare categories. For example, compare population of multiple cities, sales of multiple products, price of products. Essentially, you can compare X number of things when you're using bar graphs. Second, they also give you a frequency or distribution or ranking of the whole uh, data. You can also use this in a way to see the parts to whole ratio. For example, if the total bill is, let's say, 50, so how it is kind of divided, which day is giving higher amount, lower amount, but it does not directly show you the sum over here, whereas pi is much more a good representation for that. Just to talk about that. And again, it also helps you in representing the data with respect to time. That okay, over the year or months, like for example, 2022, 2023, 2024, how are my price moving? So you can also even use it with respect to time. So kind of a good, very good graph, in fact, very informative. So let's plot this. Let's see how do we make a bar chart. So again, simply df.group by day, and getting the size and tip sum. That is what I'm doing over here. So total number of people that came in on Friday, Saturday, Sunday, Thursday, and followed by the tip amount as well. Now, how do we make a bar chart? by simply saying plt.bar, as simple as that. So plt.bar allows you to make a bar chart. Now you're saying data day, essentially going on x-axis. So Friday, Saturday, Sunday, Thursday goes on x-axis. Data size, like the total number of people, goes on the y-axis. So that's why you can see 50, 100, 150, 200. Like this is the scale of the y-axis. A label, a number of people, like how many people came into the restaurant on that day. You can even specify the width of the bars. How why do you want the bars to be? For example, I specified 0.3. You can see they became a bit lean. And then alpha is equal to 0.4. How much you want to control the intensity of the color. Okay. You can even control the edge color and all those things as well. For example, if I say color, let's say green yellow. So you can see this is how it pops up. Looks basically okay. So X label a day, a Y label total number of people on Y axis, PLT dot legend that show me the legend as well, and PLT dot show me this whole graph right now. So that is what happens over here. Now you can even make stacked bar charts also. You can even make a stacked bar chart as well in uh, Matplotlib. How do you do that? And let's first of all make them also lean a bit. But the intent is exactly similar to how you are making multiple lines. How that we even without running a plt.show, you simply add multiple bars. So you're saying plt.bar, data day, size, total build number of people, width 0.3, color blue. You can have any color basically, it will be simply overlaying on top of it. Let's say gold, alpha is equal to 0.4, like the intensity of the color. You can keep it high, low, totally up to you, or edge color black. And then again, without even doing a plt.show, you use the other information, the tape, width, and a hex color code is that what we are using over here, alpha edge color. And once you run this, so this is how it looks now. Okay, and let's increase the intensity of this color as well. So this is how it looks that now this is what we call as a stacked bar chart. They are laid on top of each other first of all. So one bar and on top of that only another bar is laid. So it's a stacked bar chart helping you to compare multiple categories in a single bar with respect to any day or time. Okay, so this is what is happening over here, and then X label day green. And now you can see that once you are, because you specified label over here, tip and number of people. So when I say plt.legend, it shows me that this green color is, sorry, pink color is indicating tip and yellow color is indicating the number of people. Okay. So this is what this particular stacked bar chart is displaying to you. Any questions, anyone? So now let's do one thing. Let me stop the share. Let me share this code with everyone. Please do a revision of this from starting till this particular point. You can use your own data as well if you have some data and you want to see if you want to make graphs on top of that. Please do that. The idea again is to just simply make you comfortable with Matplotlib, make you comfortable with the code so that you feel confident that you can make graphs. It's not that you're simply going through the class and not practicing anything. That is the intent that I give you the code and you practice and see how it is working. So let me share the code. Please give me a few seconds. And then please from the starting till the bar charts, do a practice, do a revision. You can change the data set as with respect to your requirements. And once you are done, please write done in the chat so that we can move ahead. So sharing the code in the chat, please give the thumbs up to the code once you are able to download it. I'm sharing both the code and the data. So are you able to download it? Okay. So please go through the code as we discussed. And once you're done, please write done in the chat so that we can move on. Thank you. Try to run with both Toby. In one make as index is equal to false, in one make as index is equal to true, and then look at the index of the output. You'll be able to understand directly. Toby, what you're doing is the first one is concat, Toby. The second one is group by. There is a very big difference between group by and concat. Uh, in concat, what happens is you're simply gluing multiple data frames together, whereas in group by, you're doing aggregation based on a column. For example, we are doing aggregation on day. So what it does, all the entries for that day, it will first of all select them and then do a sum on top of the tip column, which is very different than what a concat is. Concat simply glues, you can say, multiple data frames together. Correct, Protik. You can only use the common shorthands for colors. You cannot use any color because number of alphabets for colors are less. So you can go to matplotlib documentation for various short forms for the color like C, B, K. Only 6 to 7 short colors are present. So you can use that, but again, it's limited to only the color part, like only certain blue, red, green, these colors. You're correct. You're not able to use matplotlib. I'm not getting output. Lakshmi, can you share your screen? Let me allow you to share your screen. And let me also allow you to unmute you because I'm not sure why it is happening. It should not be happening. Yes, Lakshmi. Please share your screen. What you are referring to. The code would be still present. Now I shared the code, so you would be having the code for how do you import it in your case then. Means you would have downloaded the code, then you would be running, then is when you will not get output, correct? plt.legend adds the legend on top of your graph indicating what that color is it presenting. For example, that blue color bubbles are representing tip versus bill. Green color line is representing, let's say, the total bill. So that is what it is. Not getting using pip. Can you share your screen, Lakshmi, or like because use this code, you do not need to have pip and those. Like we are not supposed to use pip. Matplotlib is already. Are you using Anaconda? What are you using as your code ID? Like which ID you are using for the programming part? Okay, the lab presented simply. Now, so in that case, Matplotlib is already installed over there. You do not have to install it. You simply upload the code that I shared with you and run it. It will work. It will also show you output. Is it not showing output? Can you share the screen for that then? Because I can help you resolve that error then. You're also unmuted. You can use the mic. Lakshmi, what I would recommend you is you going through uh, the first course that we had, Python for Python Programming Essentials. So I would highly recommend you to please go through that course. It will be really helpful for you to join multiple things together, honestly. So in Python Programming Essentials, if you can go through the recordings that would be present, simply go through the recordings and follow what we are doing. You'll be essentially able to understand each and everything, in fact, followed by the recordings of this particular course, the classes we have done. So in case if any error around the IDE, Python, output, input, you'll be for sure able to solve them by yourself, in fact. Okay. The same did not work in. I'm not sure why you're using the online platform of Anaconda to run the code, Ajay. You again, it's a personal choice. You can do that. That's not an issue. But in case if you do not want to do any installation, you can simply use Simplon Labs. Over there it's completely installed. But talking about the point the of Google Colab, in Google Colab you'll have to log in using your Google account, and then only it allows you to upload and use the Google Colab. You'll have to join the runtime. So for you to first of all work with Google Colab, you'll have to at least watch 2 to 3 videos of how to use Google Colab and how does it work. And before that, you should be very good with Jupyter Notebook, what Jupyter Notebook is and how does it work. Then only you'll be able to connect the dots essentially of how the whole thing is working. Yes, Lakshmi, that's okay. You can use the dash dash dot. labels, Pratik. Like if you look at the page which the snapshot is shared off, if you simply look at that page, so a dash indicates a dashed website, a dashed line, and dash dot indicates a dash dot. So you can use those as well. Okay. In line style, you do not mention the color. In line style, you only mention the type of style of the line. Will it be a dashed, or will it be a dash dot, or will it be a simply dotted line? Okay, so line style indicates that. We tend to use color, line style, marker in a single go in the short code, which again is only limited to certain colors. Line style is an independent argument, Pratik. Yes, Ajay, you can change the background color as well. So you'll have to specify other pieces of code for that, but yes. Yes, Pratik, you can. So I hope everyone has gone through the code, correct? Any questions, any doubts, anyone? So Pratik, it can be changed, but there is no direct command for it, honestly. But it can be changed, in fact. You can use styles and those things in case we'll talk about those things in the upcoming sessions. Okay. I hope everyone also have completed the code. Okay, perfect. So let's move ahead. Okay, let's do one thing. We'll continue the same from tomorrow's class because we need to talk about histograms from tomorrow then. So because we'll be talking about bins and those things, and those won't be completed with the time that we are left with. So what we'll do is we'll cover the histograms in tomorrow's class, and yes, in case now if you have any questions, please post in your questions. In case if you do not have any questions, I've shared the feedback link in the chat window. Request you to please provide feedback. Uh, Only five is termed as good, less than five is not termed as good. You can rate accordingly, and you can also provide your comments as well. So thank you everyone, those who are dropping. And in case if you are having any questions, please post. Then you can provide the feedback, and then you can drop as well. So thank you everyone. Thank you, Bharat. Thank you, Pratik. Thank you, Jay. So the Plotly is not completely free, and also Plotly has its own lot of things that you can learn. So we'll talk about Plotly from the overview point. Again, Matplotlib is the initial library that anyone entering data science should learn, because C1 is also built on top of it. And once you are aware about how they work, learning Dash and Plotly or learning Bouquet is not a difficult task. Then that's why. Thank you, Jay. Thank you, Prajita, Gender, Sundar, Ajay, Sudhir, Siddharth, Abhishek, Sayed. Thank you. Thank you, sure. Request you to please provide feedback. Okay. So I do not see any questions coming up. Thank you, everyone. See you in tomorrow's class. Till the time, have a good day. Thank you.